Yeah. So guys, in today's session, we'll be doing one end-to-end project. Okay. First of all, I will give you the use case that we wanted to implement, right? So let me present my screen for that. Yeah. So as you see my screen, just wait. Let me see. But yeah. So the use case is talking about smart mobility optimization. Okay. The objective of this use case to improve urban mobility services by analyzing vehicle routes, traffic incident, and citizen feedback to provide a real-time historical insight for better traffic planning and vehicle allocation and customer satisfaction. Okay. So basically, in any city, the traffic incident, customer feedback, right? Real-time customer feedback, vehicle routes, right? Based on all the data that we are getting, we wanted to generate some insight so that could help respective authority for better traffic planning, vehicle allocation, and customer satisfaction. That's the main goal of this end-to-end use case. We'll be implementing this end-to-end use case on AWS stack. Okay. Let me first start from the scratch that how the design would be for this use case. Okay. And then we'll go on a one by one implementation side as well. First of all, guys, what we will be doing, we'll be creating, we have first of all multiple sources. The streaming sources, okay. Let me just, right. If you remember in earlier sessions, we worked on some streaming sources like Confluent Kafka, right? One of the examples. So we are getting data from streaming sources plus APIs, okay. There are few APIs which will host their data and we will consume the data from those API endpoint. Okay. So we have streaming sources, API sources. Okay. So I'm here. I have other diagram as well, but I wanted to just start from the sketch so that you can understand. We have streaming sources, API sources, right? And there are some systems as well, right? Maybe just let me take any. Yeah, there are some system as well. Okay, which will push data to our endpoints. Endpoint in the sense, and not endpoint, basically our data lake. Okay. So this entire solution we built on top of S3 data lake. Okay. This entire solution is on S3 data lake. In S3 data lake, where we are putting all this data in one of the bucket in. So we have multiple layers over here. Okay. This is a raw layer, right? That's what we are loading data. So this is the S3 as a, this entire thing is S3. Okay. And in S3, we have created one bucket with the name of raw layer. Okay. All these solutions, we are getting data into this S3 bucket. Let me just make it better. Yeah. We are getting the data into this S3 bucket from all these solutions. Okay. How and what we'll be doing for that, I will cover soon. Okay. So when it comes to streaming sources, guys, we talked right earlier the Kafka use case. I give end-to-end Kafka use case, right? What are all the things in Kafka? We have the producer, Confluent Kafka, right? We have the producer, message producer. Then we have message consumer. Uh, we also talk about the concept of broker, replication, and all, right? So all these things would be relevant over here as well. So Kafka is a streaming source. We have Confluent Kafka, right? Now, guys, the API endpoint. We know that creating the Confluent Kafka cluster is very simple in a Confluent community edition. Confluent edition, I can just log in over here and create my Kafka cluster. But before that, before loading data into my source, right? I mean to say, before loading data into my raw layer, my these systems which are sending data, they should be ready. So first of all, API, right? There is one application, okay, which is exposing API. Okay, how to build? As a data engineer, you let's say if some request come to you, okay, create some API endpoint, and so that we can ingest that data and take it to the next layer. Okay, so how to create any API in serverless fashion, right? There are multiple ways to create API. You can build one cluster, let's say Kubernetes cluster, and deploy your application. But that is more on because that need your you need the DevOps knowledge as well, right? Kubernetes, Docker, and all, right? But being a data engineer, if someone asks you to okay build one simple endpoint API and that too cost-effective manner, right? So how we can do that? So let first target this API part. Okay. So what I'll be doing now, I am going to my Lambda, okay, AWS Lambda. Okay. So Lambda we talk, right? It's a serverless functions, a serverless ability, right? It help you to create the function using serverless ability, right? So you don't need to create, let's say, if imagine guys, if someone want to create a host API on some system, okay. Earlier days, what people were doing, they were launching the EC2 instance, right? Then deploying their application and exposing that as API, right? So that was more challenging and not cost effective, right? Your EC2 instance should be running 24/7. But the way Lambda work, the moment, let's say, your Lambda would get request, you will be getting charged for only that specific duration. And your application is still 24/7 available. That's the main benefit of AWS Lambda. So let me create one Lambda. Okay. Response from API. Runtime I will be using Python. Okay. And other let it be all the things let it be as it is. I will just create a function. Okay, it shows that function is created. Right. Now guys, I will be writing some code in here in this Lambda. Let me just, it's a very simple because in actually what we'll be doing in your Lambda, you will be writing your own business logic, right? I know that this Lambda would give me some data in the form of, let's say, some array and all, right? So I just form that simple Lambda function, create that simple Lambda function. I will tell you what this Lambda function would do. I just click over here, Lambda function, right? Let me minimize this. Yeah. So I'm in Lambda, and then if in the code section, you would see the entire code, right? You just let me just this paste entire thing over here. I will explain what this Lambda function is doing. Okay. This Lambda function is nothing but raising the incident. Okay. So all the incident, of course, in actual real world, you will be having some incident generated by this Lambda function. What this incident are the incident which are which arise in the on the road, let's say, when people were driving, right? Let's say some incident raised by any driver or right any passenger. Those incident we are capturing via this API. Okay. This, if I just show you what is in this API, right? I'm just showing it in you guys in Notepad++. See, it's a very simple Lambda handler, and I have just array of incident, right? In actual world, you will be having multiple incident, let's say generated by, you can maybe connect to another system to get these incident. Currently, I have just used this incident as it is over here, but maybe in your project, you can use this Lambda to connect to, let's say, some another system, pull that data, right? And get this all incident record. Currently, I have just hard coded over here, and that incident I am passing as a response in the form of JSON. That's so simple Lambda I have. So let me again go over my Lambda function. Okay. So this is a simple Lambda function, guys. So generally what people do, let's say in Lambda, they can connect to some another system, right? They can even connect to some another system. It could be anything. It could be some file system or database system. Second, let me explain this part as well. So people can your Lambda function. Let me add a Lambda over here, right? Your Lambda function would connect to this external system, right? And can get that data. This external system can be DB, it can be files, anything, file-based system, right? It can be anything, right? It would pull that, this Lambda would pull that data, right? And it would return. But we want the data in the form of API. What to do for that, right? Because we are from the other end, we'll be calling some API, and Lambda cannot give data in the form of API. So what we'll be doing? Now, guys, what I will do, I know that, okay, this Lambda I have created. Now, let me click on add trigger. Okay. Let me click on a source API gateway, right? If you wanted to, whatever Lambda is doing, if you wanted to return that as a API, you can use API gateway. You use the create API gateway. I will use HTTP, right? Security, I will use just open. I don't want for this demo to add any authentication or authorization. I'm just keeping it as open, and I am clicking on add. So I have created now API gateway, and you see this line, it's, let me take a marker. You see this line, it's this API gateway indirectly associated with this your Lambda. Now, if you click on an API gateway, and if you just click on this URL, it's a hello from Lambda, right? So you see, if you go to the code of the Lambda, earlier we just added that code, new code, but we not deploy. So remember, anytime, let's say if you wanted, if you make any changes in your code, you should always deploy your Lambda. Why hello from Lambda? Because earlier, very first, it was just when you create any Lambda function at the start, it just returned hello from the Lambda, right? So Lambda successfully deployed, successfully update the Lambda function. Okay. Now let me refresh this page. You see, I got some data in the form of API. Now what I will be doing, I will be using this API endpoint to consume data. Okay. So I will just keep a note of it in another tab. Now I will again share my endpoint. Sorry, Lambda code. 1 second. Yeah. Yep. So now you see, the moment, let's say I click over here, I got the response. This response I have got, this response I got from the Lambda. So here, if you go to the diagram, not this diagram, right? The API gateway. there is one API gateway which is giving you API endpoint. I will just name it as a API gateway, right? This API gateway is giving you endpoint. Your Lambda is calling some external system, right? Currently, I have just hard coded the incident in my Lambda function, but your Lambda function would call this API endpoint, right? And now this API is ready, right? This API, whatever I showed, that API is ready. Now there would be some another system which will be calling this API. Okay, that's what we'll be doing now. So first of all, guys, in any big data project, when you start very first, you just know it's a data. First, we'll be focusing on getting that data right from all other systems. Okay. Yeah. Right. So now let me use some. Now, guys, our API is ready, but how to ingest that data, right? To ingest the data, we need some notebook and all. Okay. So we will be creating AWS Glue. You remember we already create Glue notebook in our solution. So I will be using AWS Glue. Okay. To this AWS Glue, what will it will do? It will collect the data from this API endpoint and load into the S3 bucket. That's the purpose of this AWS Glue. Okay. Okay. So this API called by your code in AWS Glue, and then this AWS Glue will load data into your raw layer. So let's do that. I have one raw layer. So first of all, before that, so since this API I need to load data into the AWS S3 in the raw layer, let me go to the S3 bucket. I have created already one S3 bucket. Let me show you this guide, right? So this is my name of the bucket, smart. No, this is I think user S3. Let me click on open new tab. So see, smart mobility data is the bucket that I have created, right? We are having multiple layer over here, but let's first focus on a raw layer. Okay. In raw layer, I have multiple data set. So incident is one of the data set. Okay. And let me delete this file. I have already trying these things. So let me delete this incident.raw. Let me close. Okay. So I have in the raw layer, I have incident. So this is my S3 bucket, right? This is my nothing but a data lake. In data lake, I have raw, enrich, and business. So first of all, I am loading data into the raw layer. In raw layer, also the incident that I am getting from traffic system, right? Those incident I am capturing as a CSV. For that, what I will be doing, as I mentioned in this diagram, right? As I mentioned in this diagram, I will be using AWS Glue to get this API data and load into the raw layer. So let me do that. Okay. Yeah. So let me do that. So I am going to AWS console. Okay. Clicked on AWS Glue. So basically what we are doing guys now, we are forming the data ingestion layer, right? Data ingestion services. So there are multiple services which will help us in data ingestion layer, right? So let me mark it as this entire thing as or instead of this, let me take. So data ingestion layer, right? One of the things that I'm talking in data ingestion layer that I have the, let me mark it right. In data ingestion layer, the API is one of the things that I have, right? API is one of the things that we are doing now, plus Kafka also will be doing, right? So all these are the data ingestion layer. Fine. So now let's go to the AWS Glue, right? And click on a notebook because I want to call that API which I just created and get the data from that API. So as explained in earlier sessions, AWS Glue is the service that help you to create the notebook, right? Low code ETL plus code base ETL. So in this approach, we'll be using the code base ETL. So when you go to the AWS Glue notebook, you will be having, you can create one new notebook. Okay, I have just created one notebook. I will just quickly take you through that. What is the logic I have written in that notebook? It's a very simple one. The moment you click on a notebook, it would start, right? So in earlier session, we went to write all the ETLs, visual ETLs, right? That is a low code based solution. Then notebook ETL, that is a code based solution. All these things we went to. So now with and the code based solution is nothing but the our Spark based code, right? Which we discuss, right? In earlier sessions. So my notebook is ready now, right? You will be, the moment you create the notebook, you will be getting some in the built-in code. You can just ignore. Okay, ignore in the sense. See, I can show. Okay, so the moment you create the notebook, you will get this code by default, right? Why? Because the way Glue work, right? It don't directly work with the Spark session, Spark context. It work with the Glue context. So that's why by default it create the Glue context for any notebook that you are creating. Okay, so this is by default code you will be getting. What we are doing over here, we are getting the Spark session, getting the Spark context basically, then convert casting that into the Glue context, right? And then from the Glue context, we are getting the Spark session and now starting our Spark job. Okay, because to write any data processing, we need some PySpark uh, job, right? Sessions. But Glue work with Glue context, not the PySpark or Spark, for example. So let me click on run this time. So it started. Let's wait for some time. Now guys, this Glue API, Glue would call that endpoint API and load data into the S3 bucket. Okay, I think it's in starting state. Okay, it's a okay waiting and now session created. So we got the Glue context ready. Okay, now our main code, writing data into location in S3. Which data we are loading, guys? The data that we have exposed via this endpoint, right? This is what you are seeing, right? I have created this API. Now I want this API data to get read by this notebook. Okay. What I will be doing, I will be just adding that API URL over here. So let me explain this code. First of all, we are getting the Spark session, Glue context, right? And then from the Glue context, we are getting this. Once we got the Glue context, then we are getting the Spark session out of it. Okay. Now we are calling one API endpoint. Then from the API endpoint, we are getting the response. Request.get the API URL. Then we are getting the response. Okay. We are getting the response. Now we are checking if response is not 200, then something error. Otherwise, response we are converting into the data, that is response or JSON we are calling, because this entire data is in JSON form, right? This is JSON format. So we are converting that into JSON over here, right? We are converting that into the JSON. Then from the JSON, whatever the data that we are getting, we are converting it to the Panda data frame, right? Just printing that data, and we have S3 bucket, right? And in that S3 bucket, this is the S3 bucket that I have, right? And this is the path of this S3 bucket. In this path, with the help of Boto3 client, you remember in earlier session also we use the Boto3. Boto3 is the one of the library to connect to all the AWS services. We can connect to all the AWS services with the help of AWS S3 Boto3 client, right? Any services you take, name, let's say S3, your then AWS Glue, Lambda function, all the services you can connect via your Boto3 client and the service name. In this case, S3, right? So what we are doing over here, I am converting that pandas data frame to CSV, okay, and then calling S3 bucket dot put object, because I wanted to put that data, right? Where I wanted to put in this path, S3 path. What is the name of the file? This file, and the body entire the CSV buffer that I am getting, right? I'm just using this string I have CSV buffer. So entire CSV buffer dot get value, entire response that I am getting, right? That response I am passing as a output over here, right? In S3 bucket. So that's a simple, basically whatever the response that I am getting over here, I am passing that as a output in S3 bucket. Okay, let me run this section, guys, as well. Click on the, yeah, it's fetch data from this API, right? Response from the API, and guys, loaded data into the S3 bucket. If I just go here, okay, incident, let me refresh. You see, we got the data, new files over here. So basically, in your project also, you will be loading data from multiple systems, right? One of the system is API endpoint I have you, right? So there could be multiple API that you will be calling via your own services and loading data into the raw layer, right? So one of the things that I have just explained. We'll be also calling the data via Confluent streaming services as well, right? There are some data that people are, let's say, this is the API incident, right? But let's say you are getting data from the stream. Let's say people from the mobile phone directly giving some alarm or incident, right? Those incidents we are capturing, and we are capturing that via Confluent Kafka. Okay. So those Kafka message we need to get and load into the our raw layer as well, right? So this is also data ingestion we will be doing. Okay, fine. It's not this one. So basically the Kafka data, right? So AWS, let me quick go. So the way we are getting data from the these services, API services, we'll be also need to get data from the Confluent Kafka as well. So for that, guys, before going to that Kafka part, imagine, guys, in my S3 bucket, there are already some data. So what are that data? Let me show you. So one of the data I am getting from the API, plus there are some more data sets like feedbacks, okay? Raw feedback.csv. I will be explaining via code what is there in this feedback. In any big data project, when you start, it just data, you don't know anything out of that data. So that's how, right? You have raw feedback, incident we just loaded, right? With the help of our API based mechanism. Routes also we have route.csv, different route that are available in that particular city, and schedule. What are the schedule of different vehicles that going through from one location to another location? So all this data also I have. So I have total these 4 layers, right? And I have one Kafka layer as well, right? Which will be which I will be talking. Okay. So first of all, before going to the Kafka, what we'll be doing now? Let guys go to the our this solution. Okay. I have data into the S3, right? And I need to move. I need to first of all read this data, right? To understand what is there, right, in this data set. So let me do one thing. I will first of all go to the Confluent edition. We will, what we will do, we will at least make our source endpoint ready. So the way API is ready, right? This system I will tell in some time, but let create a Kafka cluster as well. So I will just create the Kafka cluster, not actually create, I will just log in over here. Okay. Okay, I just logged in over here, and now let me go to the our all workspaces in Databricks. So this is a Databricks based solution, right? Entire solution we are building on top of Databricks, plus we also use a AWS Glue as well at some place. So if you go with this diagram, this entire solution is on Databricks data processing. At a compute layer, we have Databricks. Okay. Fine. Now we have, let's guys create one simple notebook. Okay. I have that notebook already over here. This is just simple Databricks notebook. Okay. Let me name it as a notebook. So this notebook, what will do? It will first of all read this data from S3. Okay. Read this data from S3 and create few tables in DBFS layer, right? So let's see what this notebook is doing. Now I'm into this notebook. So I logged in over here, right? As you see my screen, I have this, let's say AWS folder. This is how the multiple notebooks that you will be having in your solution. So data ingestion layer, right? Raw data staging. So S3 data ingestion. So that is a notebook that I am talking to, right? So first of all, to connect to this cluster, I need to create the my first of all, to create a Databricks service, I need to create a cluster, right? I'll be creating it with a cluster with the name, let's say cluster, for example. Demo cluster, right? Create compute. So this cluster is required to run your Spark job. And I know that since in this case, we are dealing with the Confluent Kafka library as well. So I'll be installing one library over there, which I also installed when we went to the Kafka streaming. So same thing. Let this cluster get up and running. Let me go to the AWS once again. Data ingestion, raw data staging, S3 data ingestion. Let me click on demo cluster. So the moment, let's say demo cluster is ready, it should show connect. So any a database cluster, right? We were talking that earlier that in the cluster is the main thing, that it's a form of the multiple VMs are combined with each other, right? To give you multiple throughput, multiple RAM, better RAM, right? And better processing capability. Creating the cluster is very difficult, right? If you go with the VM based solution and create the cluster, right? It need the network expertise and other thing as well. But Databricks make us very simple, right? Just you go and create the cluster in the Databricks, right? So the cluster that I have created over here, because I am using community edition, I just use a simple runtime of this one, whatever the latest runtime. The memory 15 GB, 2 cores, and all this detail I have, right? So 2 core I have, and I have created a cluster with a 15 GB of memory. So now let's say guys, in this cluster, sometime you might have the requirement to connect to external entity, like let's say Confluent Kafka. For that, you need to install some library. So here, since we are trying to connect the Spark with the Confluent Kafka, I'll be installing this Kafka library over here. So this library got installed. Let me go to the workspace. Clicking on Azure, data ingestion, raw layer staging. If I go to my catalog, let me see if there is any table. I shouldn't have any table. Let me even go to the MNT path as well. This is the path, guys, which I explained in earlier sessions, right? In your location, whenever you are creating Databricks cluster, right? There will be MNT location attached to your Databricks, okay, which we can use to create external tables or external file system. You can create that your database and load into the your MNT path. In that case, even if you drop your table, your data would be still there, right? So that's the purpose of MNT path. And all the table that you are currently, I don't have any table. If you create any table without MNT path, it would go to the user Hive warehouse directly. So that's we did discuss in detail in earlier class, right? So currently I don't have anything over here. MNT, only data lake is a folder that I have. What I will be doing now, I will be deleting entire thing from this thing from MNT, right? I don't want anything in to MNT location. Okay. I will show how I'm doing that. And database table, I don't have anyone. So let me go on data ingestion. So you see MNT user have whatever I'm just doing the cleanup, guys. If there are any directory, I'm just running this command. dbfs fs rm. dbfs utility is nothing but the Databricks utility service file system, because it's a database file system, and rm removes the command. And what you are removing, all this data lake folder. Now if I go to the catalog, dbfs mnt mnt data lake equals to, I think I just need to refresh, maybe it would take some time. Okay, from the data lake there is nothing here. I just, what I did, data lake and enrich, data lake and checkpoint. All the directory within a data lake I have deleted. So in data lake, I don't have any directory now. So all the cleanup completed, right? Completed, guys. Now, guys, to connect to S3 via our database solution, there are multiple way. The simple way I'm just using for the demo purpose, I have created one access key and secret key. In earlier sessions also we did these things. So let me show you what exactly we did over here. I create, guys, one simple username user over here. Okay. I have created one simple user name of the, how I created, just in AWS, I go to the user detail and all, right. So earlier sessions also we covered these things. So I create the one simple users. Okay. And I apply some policy over here. What the policy I have give, the JSON policy I have give over here to this user, I give the access to my S3 bucket. What access? It's a gate access. First of all, I gave the gate access, but then later I also give the full access over here. So basically what I'm trying to say, with the help of this user, I have full access to my S3 bucket. And then I create the key, access key. So if you see this access key, what I have created is nothing but the key that I'm using over here. Right? So this is the key I'm using over here. Right? Now, this key is having access to only this bucket, guys, not all the bucket in my S3 location, just for your reference. Okay. So I have this access key and secret key created, right? And now I'm just encoding this secret because as per AWS, we just need to encode secret as it is. But in best case scenario, you can put this access key and secret keys on some another secure location and get it from there. You can use a DB secret as well, right? So all these things are possible, but just for simplicity, I have coded this as it is over here. This is my bucket name, right? Now, what I'm doing, I told you, right? I have already some data in the feedback, route, and schedule folder, right? Let me run this code. So it's starting. It started a Spark job, and see, we are getting the data. for all the three layer. Okay. This is how the data it's showing that just top 20 records. But see you, if you see the feedback for the feedback, I have feedback ID, route ID, for which route the feedback is, customer name, right? Comment and all these things, rating and all I am having data. Then the way I have the data for the feedback, same the route ID, route name, origin, destination, kilometer, all this data I have for the route as well. And similarly, for the schedule also, the schedule ID, route ID, departure time, arrival time, all these things, and day, all these things I have in schedule. So all this data I am having in my S3 bucket, right? This S3 bucket, I have this data in respective folder, feedback, route, and schedule, that I'll call and just call the show method. Okay. What I am doing for each one, I am just passing a raw schedule, right? Spark.read.option header equal to true, because I am getting the header equal to header, right, in each result, right? Header I am getting, right? Header equal to true, and data is in CSV format. That's why I give the CSV path, and then just calling route schedule.show, right? So this is the simple thing I am doing and showing all this record. Now, guys, fine. Now we know that I can connect to my data source and get that data. Now, what we will be doing? We will be creating the table in Databricks file system from the data which we are having in S3. That's a common practice whenever you are developing something, let's say in Databricks, you read data from S3 and create the database, create the table in Databricks itself. Okay. So the bucket name for route, I am creating the raw layer tables. Okay. What I am doing, I am just reading this path. Okay. Getting that raw route. Okay. And then what are the data that I will be getting? I will be getting, right? Earlier, I just called a raw route dot show. Now, what I'm doing, raw route dot write mode overwrite save as a table. So this should create some one table for me. Okay. So table one is getting created now. Raw layer table. So we create the raw layer table. Similarly, let me create a raw schedule table as well. So here also I am just getting data from raw schedule file path. Okay. S3 directory. Reading that file, because you remember I told that I have some CSV file already there, right? So I'm reading that particular file and write mode as a, I'm just using write that data frame in overwrite mode, save as a table, raw layer schedule. So let me do that one as well. Okay, this table also got created. I will show all this data, and then similarly for feedback table, feedback as well, right? So I am reading data from the S3 bucket raw feedback location. You see raw feedback location. I have this S3 table, CSV file, right? I'm just reading that particular file path. Then I am giving spark.read header equal to true and giving the path of the CSV. And then once I got this data frame, the data frame dot write mode override raw layer feedback. The simple thing that I'm doing, I'm creating the three tables in my data frame. Sorry, Databricks. Right. Okay. Now let me, right. So I have created a three tables guide, right, guys, right? So if you go to the catalog, you see three table got created. These three table are nothing but the CSV file I already kept in my S3 bucket in this respective folder, that is feedback, route, and schedule. But you remember I have incident folder over here as well, right? Incident folder. In this incident folder, I have loaded data via AWS Glue. Now let me read data from this AWS, sorry, read me data from this incident folder as well. Okay, so what I'm doing, first of all, let me show you. Read the file via API hosted by Lambda and load file in S3 bucket. Okay. So whatever the Lambda that I have created, which are hosting one API, this API, right? That data I am calling via this notebook. Okay. So that API already we called via our notebook, right? This notebook, via this notebook, we already called that API and loaded that data. Now, anyway, let me stop this notebook. That is not required because its job is done now, right? So let me focus on this, right? So now we have file loaded into incident, right? I show you that incident.csv. So same, I will be reading that file and just showing that the content of that file. Okay, I think it's just okay. It's completed within a second. So you see, this is how the data look like in that incident.csv, right, guys? Incident, location, in which location that incident happened, severity, and timestamp. So basically, data that you are seeing over here, right? Incident, location, severity, and timestamp. Then again, incident, location, severity, and timestamp. So all these data I am getting as a form of JSON. Okay, sorry, we loaded into the create a table out of it. Let me just make a marker. Okay, fine. So let me create a table also from this raw layer table. So I have created this raw layer table. Okay, now if you go to the catalog, we'll be having multiple tables: feedback, routes, schedule, and incident. Okay, these are all the tables that I have created. So if you think about the design wise, right? So we are reading data from via this notebook, and then we are creating the DBFS table as well, right? So let me see if there is a, yeah, let me call it as a DBFS tables. Let me stop that one. I will be just using some simple thing. Yeah. So we'll be creating multiple DBFS table. Okay. In where we created at a DBFS location. Right. So in DBFS, we are creating the we have created a multiple tables. Okay. Let me take this and okay. So these are multiple tables I have created in DBFS layers. How I have created it? I have created, I have read data from S3 and create a table in DBFS layer, right? So now move to the next things. Now guys, we also need to connect to the Kafka data source as well, right? So let me go to the workspace, streaming data ingestion. So what I'm doing in this code, guys, I'm just connecting to, first of all, I am creating, you remember early in I explained you in earlier session that how to create a schema and all, right? So we are just creating the schema and then we are connecting to the Kafka. How? With the help of this bootstrap server and then vehicle topic as well, right? This is a topic. So first of all, let me go to the Kafka topic, basically Kafka cluster. So this is my Kafka environment. Let me go to the home and then environment, default. Let me click on a create cluster. I will be creating the basic cluster, right? So my cluster got created. Now let me create a topic as well. Create a topic. And I need a 4 partition in this topic. Create with the default and skip. Okay. Rest of the thing, let it be as it is. So in cluster, guys, because we are creating multiple time this cluster across various sessions, I will be needing this bootstrap server ID, right? So bootstrap server ID generally not get changed. So at least because this is my cluster, so that's why it's the same for me. I'll be just closing this. Okay. So this is the bootstraps ID that I have. Okay. And then what I will do, I need credential as well, username and password to connect to this Kafka cluster. So let me create that, guys. So I am in my Kafka cluster now. Let me create the API keys. Let me click on a create key, my account, next. Okay, these are the key and value. Let me just copy it. So this is my key to connect to my topic. Topic I have already created, right? And this is a value. Sorry, this is a secret value. Okay, let me just copy it. And just delete it, and let me save this entire value, right? So I have copied this. So what this particular piece of code is doing, it's connecting to the Kafka cluster to specific topic, and it start consuming that data, right? Uh, Once, let's say, whenever you're doing spark.stream, it's a continuously streaming call. It's continuously connecting to the Kafka topic. Then from the Kafka DF, I'm getting the value, right? Select expression. I'm getting the value, right? Because in Kafka, you store data in the form of key and value. So I'm getting that value, right, as a JSON string. Okay, JSON str. Now from what I'm doing, basically I'm creating one new column that is JSON str, in which it will contain all the value that my producer sent. Now I am applying from JSON function on that particular JSON str and applying this schema on top of that, this schema, so that I will get data in the proper schema form, right? Not in JSON form, and just giving alias as a data and then select star, select data star. So whatever data they are getting, I am just taking all this data and then writing the data, guys, into as a delta mode. Okay, delta append and particular basically location. This location I am writing MNT data lake raw layer vehicles stream. Okay, this is the location, guys, wherein I will put this data. Whenever you are doing Kafka streaming, you will always need to give the checkpoint location as well. So that's why this checkpoint location also I am giving from my DBFS file system. So now before, so first of all, let me now start this Kafka streaming job. Okay. Before that, let me, so now this is, see, since we have Kafka consumer, we also have the Kafka send producer as well. So let me copy this. Let me share my another screen. So I'm just taking the, let me show you my, in earlier sessions also we did these things, guys, the Kafka and all these things. It's not something first time we are doing. I took the username and put over here, right? And then I will also take then the secret as well. I just copy the secret. I post that secret over here as well. Okay, fine. So I will just saving this. Okay. Now, once I save, guys, now this is the producer. Okay. What is producer? This producer is also doing the same thing. Basically, it's connecting to the Kafka. It's connecting to the Kafka. How to connect? I have you all the details that, okay, this is the Bootstrap server, username, password, and I'm just passing some dummy message in the form of array, right? So I have this vehicle ID, route ID, current location, right? Current location, and then speed, timestamp, status, and passenger count. All these data I am passing. This is the array, okay, and all the data I am passing one by one to topic, vehicle topic, which I have created in my Kafka cluster, right? Vehicle topic I just created. I'm just doing producer.produce, right? And then printing that message. So now before starting producer, let me, okay, let me just stop share for a second. Let me store that key and val. Okay. So let me reshare once again. Yeah. So if you see now, let me share once again. Yeah. So let me share. As you see my screen. So what I will be doing now, I will be starting my Kafka consumer. So as per this diagram, whatever you are seeing over here, right? This diagram, my database notebook now will start. Let me just take that this particular thing. My database, the code in my database notebook will read data from this streaming data source, right? And creating another tables in DBFS layer. Okay. Let me show you that thing. Okay. So for that, I have another notebook, streaming data source notebook. Let me go there, streaming data source notebook. Okay. So now this is another notebook in database itself. So you see, this is streaming data source, right? Now let me start this piece of code, guys. Okay. I think we are good here. I give the same details. Okay. Let me just check the credential and all. Just a second. If everything is right or not. Okay. Let's start this, guys. So my Kafka consumer is okay. First of all, I have to connect to my source, right? A cluster. So I have connect to my cluster, demo cluster that we have just created, right? I install library as well. I started that data. Let me, guys, now produce some record from here. What this producer is doing? Let me, I have just run this producer, the piece of code that I just show you, right? Sometime back. I have run this vehicle stream producer. It's sending record one by one to my topic in a Kafka. If I go to the Kafka cluster now, if I go to my Kafka cluster now, you can see the topic, right? Because I am passing the message to that particular topic. If I click on this particular topic, it's showing loading message. Okay, let's wait. So you see all the messages we have passed to this particular topic, Kafka vehicle topic, and now my streaming job is continuously running. See, I started, but it's continuously running. Okay, it started the streaming job. Now, guys, let me just click on this display vehicle. So whatever the vehicle stream I have created, right? Let me click on it, display vehicle. So it's a streaming job, guys. And imagine that in streaming data, you might get some duplicate records and all, right? There could be some situations that you will be getting some duplicate record. Currently, still my streaming is running, right? We can wait, we'll wait for some time. And the way I have created this notebook, even if duplicate record come, we can handle it at a source, at a processing side. So imagine, guys, we'll wait for a few seconds and I will just send some more record, because in streaming, you don't have control over data, right? The streaming sources, the sensor sources, right? Whatever, right? Streaming data, they can send data multiple time, right? And it's a your ability to write a logic so that you will not consume the same record multiple times. So now, guys, let me rerun once anyway. So I started vehicle stream once again. So as you see, so now let me just show you. You see, I'm getting the data, this data now, right? It is loading. So all the streaming data that I am getting, I have pushed from my source. I'm getting in my streaming data source, right? All this data I have. And guys, this is a continuous call. Streaming data source is continuously listening to your topic. It's continuously subscribing and getting new data. For now, what I will do, I don't want it to be continuously in running state for the demo purpose, but in actual cases, you'll be having this running in 24/7. But of course, you need to make sure that now you need to bear the cost with that as well. Now, guys, this streaming data I have loaded in this MNT data lake raw, this layer, right? If I go to the catalog, MNT data lake raw vehicle system, right? So this is how, guys, I have data over here, right? So data is in form of delta, right? All this data is in form of delta. So if you are seeing, one of the thing to highlight you guys, let me go to our diagram. See, at a raw layer, you might have the data in the form of CSV, right? CSV or anything at a raw layer. But at a enriched layer, or let me take it over here, right? So here all the data is in form of, let me label it as CSV. All the data in my this table, it could be CSV, right? The table could be of CSV, right? Read data from store as a CSV and all. But at an enriched layer, my all the tables are of delta, right? So that's the main difference. So all the table that currently we have created some of the tables, right? Only one table will. So all the table will be creating in enriched layer will be of delta. So now, fine, guys. So we are getting data from the Steam as well. So currently, as I show, if I just show you in catalog, I have this 4 table plus I have some file system data as well, right? This MNT data lake and raw, and what are the data files I have just show you, right? Now, guys, let's move to the next part, data enrichment part. I'm just click on workspace. I just click on workspace, right? Data enrichment. First of all, the live I will be creating what are the data that I'm getting, I have just got, right, from the so in enrichment layer, what we are doing, enrich the enrich live vehicle feedback. Okay, we here what we are doing, we are connecting the streaming data with the feedback data. So see, you see, I have feedback record as well, right? And I have streaming data as well. My streaming data is in this particular table. So if you notice over here, if I just go to the catalog, DBFS, MNT, data lake, right, and the raw, right? MNT data lake raw and raw layer vehicle stream. So I'm creating the table out of it. Let me create this table, guys. Let me attach the cluster. Table got created, guys. How this table got created? Because I connect to this endpoint. This is external table which I have created from the stream data source, raw, and then a raw layer vehicle stream, right? Raw layer vehicle stream. Let me run select query on top of this data. You see, I got records over here, and I might get multiple records. That's fine. Duplicate record. I will build a logic to make enrich layer just to, because from the streaming sources we might get duplicate records. So we should build a logic in our solution so that we will always receive the unique record. Okay. So I have loaded this table. Okay. And then I'm just reading that particular table as a data frame, right? Spark.read table. And this is the delta table only, right? I'm just reading this table as a data frame. Then what I'm doing, I'm dropping the duplicate from this particular table. Okay. So now I got a unique record. So though earlier, if you see, I got some not a duplicate record over here, right? With their enrichment layer, I just removed all duplicate data and create the enriched data from this one, right? Now what I'm doing, I'm the unique record that I have created, right? And the feedback table that I have, raw layer feedback. This raw layer feedback, right? These are all the delta table. I'm joining these two table. okay, based on route ID. And then the lib join I am applying over here, and on that, from that join, I am just taking all these data set, that is vehicle ID, route ID, current location, speed, all these things. Okay. So it's a simple lib join, guys, right? Join I am doing between two data frame. Okay. So unique vehicle join, vehicle DF, join feedback DF on a route ID, lib join, and select all the data that we are having over here. Okay. Once I got this join data frame, I am writing the data frame into the enriched layer. Okay. So let me first of all run this. So enriched layer in the form of delta, and then of course if there are duplicate and all, it should, or let's say schema got changed. Then I have also mentioned, in my case there is no schema change, but in case if in future there is some new schema come from the source side, that also get adjusted into this particular external location. So that's why I mentioned this merge schema equal to true. Mode is overwrite. I am just overwriting all the data and saving to this external location. Let me run this, guys. So I have created, right? Now, if you go to the catalog data lake enrich catalog MNT, see we got a raw and enrich layer as well, right? So in enrich layer also we have the delta tables. So in enrich layer, so imagine in a raw layer you will be always having basically data that is coming from the source in as it is form. But when you are moving to the enrich layer, you will be always, it's a good practice to create the data in the form of, create the data or store data in the form of delta layer. Okay. Because I explained in last session, right? Delta give us ACID transactions plus offset operation and all these things. So that's a delta lake architecture. That's what we are building over here, right? So I created this external table. I am now creating the table. I have created basically path, not the table. Okay. I just loaded that data in this path. I am now creating a table. Before creating table, I am just checking if already table is available or not. If not, it will delete. Now the data that I loaded over here, right? On that data, I am creating the Spark table with the name enrich layer live vehicle feedback spark.sql. Okay. So it ran. Let me run now this code as well. So you see, we got all the enrich layer data. So if you see over here for vehicle ID, what the, for vehicle route ID, what is that current location of that vehicle, its speed, right, in kilometer, timestamp, rating, all these data I have got over here, right? Currently, we don't know. See, basically, when you work on big data project, you will not know. You will be basically joins data, any data and join data between, of course, unique keys and all, right? Join key and all, right? And then you will try to get some insight. So currently, I know still you might not get any insight of this data, but at least you join two data set, stream data set with the static data set, right? And okay, you got some idea. Okay, we have vehicle ID, route ID. This vehicle on this route is running on this speed, right? And what timestamp, and this person give the feedback of 3, 2, 1, right? All this data we got. So we'll generate some more insight out of it in upcoming now as we progress, right? So I have this table now in this layer live feedback. Now guys, whatever data that I have in this layer live feedback, I'll be writing that. So first of all, let me run it, and then I will, yeah. So you see what I did now, the data that I have, this entire data, right? I am loading that data into S3 smart mobility data at an enrich layer. If you go now at enrich layer, you should see enrich layer live feedback. We got also response now only, right? We just read. This would be, this is the data, how it look like. But if you go to the S3 layer, right? And if you go to the enrich, you see enrich layer live feedback is another data set that we created, right? So in terms of diagram, see I am creating delta table while processing, but that delta tables I am now loading into my enriched layer. Enriched layer, right? And this entire solution is anyway on S3, I told. This entire solution is on S3. Okay. So here delta table and files also in enriched format. Sorry, file also in delta format. So let me just take this over here. So currently from the in source, I can have CSV files, but in the enriched layer, I will be always having delta table. Guys, it's a common practice that you will be using both things. You will be using notebook, Databricks as well, plus S3 as well. So when you are processing data, in intermediately, you will be creating the tables in Databricks, and that table then you will be loading as a files in enriched layer, right? So that's a common practice. So that's what we did over here, right? Now, guys, we run one enriched layer. I have three basically notebook in enriched layer, right? And in each layer, now let's say another enrichment. In this layer, incident impact, right? So we are getting incident data, right? Via API, we load the incident.csv and then create a table out of it, right? So here you see we have this incident table, right? Plus we have this route table as well, right? In my route, incident and route, right? I'll be joining these two table now. Incident. First of all, I read these two table, and then I join this two table. Incident.df join a route table. Okay. How I am joining? Incident df location contain route df dot origin. Okay. So if I just show you, first of all, let me run this. Okay. So basically, I'm joining based on origin, and then selecting all the table, and then writing this data with the override mechanism in delta table, in delta format, in enriched layer incident impact. So I'm creating another incident table over here, and I will show you. Let me attach the source, basically cluster. Right now, first of all, before going to what we have written in enriched layer, let me show you that. So incident df, right? If I just show you incident df dot show, so that you can understand what the query is about. In incident here, I have, you see here I have incident location, severity, timestamp, route ID, and route name, right? Plus incident df, I have, if I just run this, I have incident location, severity, and timestamp. Sorry, incident df, impact, sorry. In impact df, I have this thing, and in incident df, I have these things. So what I'm doing, guys, I'm joining incident df. Okay, sorry, I need to show you route df example. That's why I'm thinking route df. Just to show you that query. In route df, I have a route ID, route name, origin, and destination, and destination kilometer, right? And here also I have incident df, I have incident ID, location, severity, and timestamp. How I'm joining, guys, over here? I'm saying incident df dot location contain incident df dot location column name contain what it contain? It contain origin. If that see, the origin column is available in some of the these things, right? For example, a downtown road, right? You see downtown road over here. Then this Tech Park Road. You see Tech Park Road. So what it doing? What it is doing? It's checking. I am joining two data frame, incident df with the route df, on the condition if incident df location contain route df dot origin, then use a left join and select all the table. And then finally in impact df, this is how our impact df look. If I just show you my df dot show, this is my entire impact df. right? So I'm getting some data from this enrich layer as well. Incident DF, incident ID, location, severity, timestamp, and route name and a route ID, right? What incident, basically talk about what incident happened at which location, how was its severity, which route, right? What was the route ID and what was the route name. So all this data I'm getting via these particular things. Now, what I'm doing, guys, the basically, if you see, because I have created this table, right? If you see, I have created save as a table, enrich layer incident impact. Same I will be querying, I will be getting the same result, right? The table that I have created, I'm just running it. It just ran and I got this data. It's the same data, right? Incident, location, severity, timestamp, route ID and route name. Basically talk that what incident happened at which location, severity, and what was the route ID and all these things, right? Now, guys, this table, enrich layer incident impact, I also need to load into the my S3 bucket as a delta in enrich table, but in another folder, enrich layer incident impact. So, guys, when you are connecting to S3, this is for demo purpose, I am just using simple access key and secret key. But yeah, you can use another standard as well to secure this key in some another key vault or Databricks secret scope and all, right? That you can also use. So let me run this, guys. So currently in S3 enrich layer, I just have one folder, right? Let me run this. It ran. Let me go to the my S3 bucket. You see, I got two folder now. Enrich layer incident impact also I got. Now, guys, let me go to the third data enrichment activity. So here we are doing just batch operation. So very first enrich layer we join the stream with the batch, right? But here we are having the two batches, route the route data plus schedule data. So basically in S3 location, I have this route and earlier I showed you, right? I have even if you can show over here, I have a route. This is a raw layer, right? A raw layer route, raw layer schedule. Raw layer route, raw layer schedule. I am in this layer, I am joining these two data tables. In this layer, I am joining these two tables. First of all, I create data frame, route df join schedule df on based on route ID, right? Because I know that in both the data frame I have route ID. I am doing just inner join and getting all the tables from there here, right? And then this enrich layer df I'm writing as a delta as in enrich layer route schedule. Let me attach a cluster. Okay, so I have created this enrich layer table as well. If I just show you that data, it will also show you some meaningful insight because I join any big data project you will be joining because after joining only you can derive some metrics out of it, right? So I have joined enrich schedule, right? Where I am getting the what was the route ID, what is the route name, from where it was going to where, right? Origin and destination, district travel, departure time, arrival time, right? And the day. All these data I am getting by joining this route and schedule. Now, once I join this one, what I will be doing, because I already create this table over here, enrich table. If I go to the catalog, you see third enrich table also got created, right? Enrich layer route schedule. Let me run this SQL query. So it just ran. You see, it's the same data you will be seeing. Whatever the data that I show you above, the same things you can see over here as well. Now, I want to load this table also in S3 bucket in enrich layer route schedule. Currently in my S3 bucket, only I have two table, right? If I just refresh, let me run this piece of code as well to create another delta, uh, basically delta folder, right? In this location. and using this access key and secret key, I'm doing that. So I'm running it. It will create a Spark job and load data into the S3 bucket, right? So now if you see, go to S3 bucket, I should have 3 enrich layer folder, right? And now guys, what we'll be doing? Now we have enrich data into the S3. If you go as per this diagram, we have all the enrich data in this S3. Now via another Databricks notebook, right? What I will be doing? Intermediately, I create a table as well, right? Some of the table. Now via another business layer notebook, right? What I'll be doing? I'll be reading data from this S3, okay? And generate a business insight out of it, okay? So that's what we'll be doing now in this layer. So let me go to the enrich layer, sorry, business layer. So we have created all the 3 tables, 3 files in S3 now. Let me go in enrich layer. Now let me go to the business layer. So in business layer, guys, our goal is, let's say, help city planner to understand, let's say, high severity and high severity incident zone. Okay. See, when we join data, we could not get most out of it, but when we enrich data and then apply some joins, right, then we can see some insight out of it. So one of the example, see, it's not like in when you are doing generating business layer data, you always go to the enrich layer, but some case there might be case that okay, in raw layer itself you have better data, it's clean data, they no need to do that enrichment. So what I am doing, I am just reading that table raw layer traffic incident. Okay, then that incident data frame I am doing group by location severity and just applying aggregation on count of incident as an incident count, and then writing this entire data save as a table is in business layer. Okay, right, let me run this piece of code, guys. Let me attach cluster. So it's running. It's running. Okay. It's ran and create the business layer incident heat map. Okay. Okay. See, we create our first business layer table. Okay. Now I can just query this business layer table. See, now we can at least get some meaningful insight. I just run now, right? The location, on which location I am getting what severity of incident with number of incident count, right? So for example, in City Mall Road, I got a severity high with 1 incident, severity low with the 2 incident, right? In Greenfield Road, I got low severity with 1 incident. So all this data I can get from this data set. So this could help my city planner or right authority to at least know how many incidents are people are raising with what severity across various locations. So that's one of the things I'm just getting. Now, guys, this business layer incident heat map, right? Whatever the business layer incident heat map I have created, I wanted to load that data into S3 bucket. So same I'm doing. I'm just reading that business layer incident heat map. These are the default things, right, guys? So because I need to connect to the S3 bucket. So to do some write operation, since I am using access key and secret key, so I need to use this Spark Hadoop configuration, right? So that's the default code. But main logic is, okay, we are reading this table now, whatever table we created in business layer incident heat map, and creating data frame out of it, and that data frame I am loading into the business folder. So if you go in S3 bucket, in business layer, I don't have anything. Okay, I don't have anything. Let me run this piece of code. So it created. Now it's ran. Let me just refresh. It create this business layer incident heat map in the form of delta, right, guys? It's a delta log and snappy Parquet. earlier I told you, right? Entire in Delta table, you have JSON file, right? And checkpoint and all these things we talk in detail. So our enrich and business layer are the delta, whereas our raw layer is a CSV or Parquet or anything, right? But our enrich and business layer are the data layers. Okay. Now, guys, whatever data that we loaded, if you just wanted to review that data, it's the same. Spark.read delta, give the location of your S3 file and just run it over here. So it would show the same data that we seen in the table, right? On City Mall Road, how many severity got raised and with how many incident count and all, right? So that sort of data we can get. Similarly, let me run another business layer. Now here goal is to show average feedback per route and the location in real time from feedback stream. Okay. So we have feedback stream, right? Real time from the live vehicle plus feedback stream. Sorry. So goal is to show the average feedback plus a route and location in real time from the vehicle plus stream feedback, from the vehicle plus feedback stream. So we are getting this data, right? So if you go to the enrich layer, see what I'm doing now. In now my business layer, I am reading data from my enrich layer. Okay. So from S3 bucket, I have read that data, enrich layer live feedback. If I just show, let me attach the cluster over here as well. So water data I already loaded into the enrich layer, right? That I loaded into my business layer. I'm just doing the show. This is what the data that I'm having now in my enrich layer live feedback, right? Now, guys, what I'm doing on that enrich layer live feedback, I'm doing some business transformation on top of that. I'm doing group by route ID, current location, taking the average of rating, taking average of rating, right, as average rating, count of vehicle as a vehicle count, and then that data frame I'm loading, creating the table out of it in business layer. So here also, if I talk about in diagram, here also I have created some of the delta table in between, right? And this delta table itself, I will be loading into my business layer. So this is how it would be. So let me first of all run this. So see above things, I read data from in business layer. I'm in business layer, right? I read data from the enrich layer. Once I read, what I'm doing, so enrich layer live feedback, right? Then on enrich layer live feedback, I am doing this transformation and creating another table, business layer vehicle feedback summary. Let me run this, guys. Okay, it just ran. If I just run this query, you see, with this data, I can see that, okay, on the route 106, on this location, I am getting average rating of 1.8, which is very low. And from how many count I got this average, how many vehicle count I got this average rating from almost 10 vehicle. So something maybe city planner or right authority need to work in this case to make to improve this particular road, right? Similarly, for this route ID, right? Similarly, for route ID 103, right? In the same city mall road, but route ID is different. I am getting some better compared to 1.8, right? And from the two vehicle count, I am getting this uh, basically record. So that's sort of similarly for downtown road as well, right? So I am getting for that specific route ID, what is the rating and how many people in average gave that rating. So all this data I am getting. So maybe this could help the authority to responsible action on that, right? So now business layer vehicle feedback summary I have. Now guys, this business layer vehicle feedback summary I will be loading again in my S3 bucket in business layer vehicle business layer vehicle feedback summary. If you go to my S3 bucket, Okay, I have business layer incident heat map only, right? So if I go here, if I just run, it created business layer feedback summary in my S3 bucket. If I just refresh, business layer feedback summary, it's a delta, right? Because you see Snappy Parquet and delta log and all the, because I just did current one operation, so that's why only one JSON. But if I continuously run this maybe as a pipeline, then you can see multiple JSON over here, right? So we get another file over here as well, S3 bucket. Now the same data which I have loaded, I will be just reading via S3 in S3 file format. So same thing, guys. Whatever the response that you are seeing over here, right? And you are seeing over here, it's the same only. The only thing that when data in big data project, you might be using Databricks DBMS file system plus S3 external file system intermediately. You'll be creating table in Databricks, right? That table you will be loading as a delta table as a file format in S3 bucket, right? So that in AWS you can use that particular data for other purposes. We'll talk about that one as well, right? Now, final thing, guys, in business layer, to detect the route congestion or delay trends using schedule plus traffic incident. Okay. So basically, we are trying to detect the route congestion, in which route there is a congestion happening, right? Or delay is happening. So that's what we are trying to do. So same for that, what we are doing from the enrich layer, I am reading enrich layer incident impact, right? First of all, I in this particular notebook, I am reading data from enrich layer incident, data from the enrich layer. Okay. So once I get that data, okay, enrich layer incident impact. Okay, I think it's a repetitive. Okay, fine. Enrich layer schedule. Sorry, yeah. So enrich layer incident impact I have loaded. Then enrich layer route schedule also I am taking from the S3. So I am taking this data from the S3 buckets. Okay, I got this data. What I am doing, guys, now schedule. So when I'm read this data plus this data, I'm getting two data frame, right? Enrich layer incident impact, enrich layer route schedule. Enrich layer route schedule, enrich layer incident impact, right? I'm joining based on route ID, left join. I'm doing some group by operation and taking the and doing aggregation, applying aggregation on incident ID and severity, right? Let me run this piece of code. Okay. So I have this now create a table business layer route efficiency. So you see, we got a business layer route efficiency table. Now, guys, this table, I will just be selecting the query, right? So you see, just run it now. You see, for route ID on this specific day, I got a 2 incident and with the severity as a lowest, right? I'm making it severity, a low severity on top, because on this particular date, on this route, I'm getting these many incident with a low severity. Whereas there might be some, okay, currently I don't have in my data set at least high severity, but let's say I can even show you, right? On this route, for example, on Friday, I got total 3 incident with the medium severity. So that what they can understand, okay, maybe on the specific day only we are getting the more incident on particular route, so that they can work on that specific day, right? To streamline the traffic situation on that particular road, right? So that sort of analysis authority can do to make to make this solution, to make this traffic planning more better, right? For example, on this particular route on Monday, we are getting 2 incident, right? Or let's say for this 104 or 105 on Friday, I got 4 incident. So something must be wrong in, let's say, on Friday, right? I'm getting 4 incidents. So they can work on that actual reality that, okay, what need to plan the traffic wise, right? But this data can help them to understand, to get the view what exactly need to do where. Now, same thing guys, whatever the data that I have created, business layer route efficiency, right? I am reading that table via this access key and secret key and writing into the business layer route efficiency. So currently in S3, I just have two tables. I'll be creating business layer route efficiency as well now. So it started Spark job and now it will complete and just load data into the this location, right? Business layer route efficiency. You can even query this data from here as well, but yeah, result would be same. Whatever you query from the S3 data lake, right? I just ran it and load this data, right? Whatever the result that you are getting over here plus here, right? It's the same. Only thing is here we are querying on a table and that table itself we are loading into the S3 bucket. In this architecture call guys, people call it as we are separating compute with the storage. All our data is in this storage. Okay. All our data is in this storage, S3 storage. Whereas intermediately I am creating the delta table in Databricks and storing. Intermediately I am creating delta table and that table I am storing into the S3 bucket as well. Why? Because there might be some other use case I can generate from the data which is available in my S3 bucket. So like maybe I can connect to AWS Glue crawler, right? And get all the data from the business layer and do further processing and all, right? Now guys, we loaded data into business layer. I have now one more thing to show you, right? If you see, now we are at a business layer and we the business people can look that data and generate insight out of it, right? All these things they can do. Let me do two things. First of all, okay, let me now connect to this business layer data now. So for that, what I will be doing, I will be going to my AWS console. Okay. And let's say AWS Glue console, catalog table. So in AWS Glue, we have multiple options, right? We can create a notebook, visual ETLs, and those things, right? We can also create a crawler. What I'm doing, guys, I will be creating one crawler over here now. Okay. I'm creating one crawler over here. Okay, instead of this long name, just let me, this is a business crawler. Okay. Imagine that it's a business crawler or crawler. Crawler, I explained in you earlier sessions as well, right? So this crawler, where it's pointing to, I want it to point to S3 bucket. Okay. Where that S3 bucket is, let me see. If you see S3 bucket, we can give the specific, we can give our entire S3 bucket, but we can even give the specific folder in S3 bucket. So in this case, if I just click on smart mobility, right? Business is my folder. Okay. All right. Where is AWS Glue? Here. Just click on these guys to make sure that you are pointing to the right location. See, it pointing to the right location. If you click over here and if it come up, then you are okay. Now see, it's not pointing. Let me add this slash over here. Now let's see if this now come up. It should come up actually. Sometime I think it take a slash to connect to that. It connect to now. Did this come up? Yeah, it connecting to S3 bucket, right? And it have these tables as well. Now what I'll be doing? I am crawling all subfolders, right? Let other things be as it is. Let me add an S3 data source. Okay. Let me click on the next. Let me create IAM role. Since I am scanning the business record, I just create the IAM role because this glue need access to your S3 bucket, right? To scan the record. So that's why business scan is the role that I have created over here. Let other thing be as it is. Let go to the next. I don't have any database. Let me create a database. Right. Let me. I'm just giving the table name as the insight layer. Database name as the insight layer, and let it be. Let other thing be as it is. Right. I'm just creating this table insight layer. Okay. I'm in Oregon region. Okay. Now table got created insight layer. Let me go refresh these things. See, I got this table. Now I wanted to create crawler to crawl and create some table out of it. Okay. I am running on demand, but you can run in any time. So let me click on the next, create a crawler. Crawler started successfully. Okay. Now run crawler. Crawler is starting now. Let's wait it to finish. Meanwhile, guys, see, now I'm loading data into the via crawler. I'm creating because in business layer, I can have maybe 50 table or 100 table, right? I wanted to, let's say, query those things properly, multiple way. I can query in Databricks, but why? Because since we are at underlying, we are using S3 as a storage layer. So that's why I'm running the crawler to crawl all the tables so that I can query with the help of AWS, sorry, Athena and all, right? So that's what I am trying to show. Plus, there are a few more things I wanted to cover. So let it get run. So what it do, it will scan all the tables, okay, in S3 business layer. And now if I go to tables, let me refresh. You see in inside layer, I got this data, okay, all this data, the location and all, right. If you just click on, let's say, for example, let me click on this table data. So see, because what we did, we connect to entire S3 bucket, right? So in this case, if you see, if I just go to the crawler, see, ideally, you can connect to specific bucket rather than connect to this entire thing. So let me try to do that one as well. 1 second, let me click on a crawler. Okay, business, edit, data source. Smart mobility data, business. Okay. Instead of making changes into current crawler, let me create a new crawler just to show you. crawler. Let me click on the next, add data source. S3 is my data source, right? And then let me click on a browse. Smart mobility is the data that I'm connecting to. Okay. There also, in this case, I don't want it to connect to all the folder. For example, let's say business slash business slash, and then in S3 bucket, for example, this table, right? This one. Okay. Let me click on a view. Okay. You have some data over here. Now let me add this to the data source, create a next, create a new role, click on a create. Let me click on next. I can create the another table, or I can use the existing database. That's fine. I'm using is, or let me even better to add another database. Business DB. Okay. All over. Letter should be small in small format. Right. So let me just see that business DB table is there, database. Okay. Let me run next, create a crawler. So basically purpose is, guys, I just wanted to show you that we can run a crawler and see all the data that you are seeing in S3 bucket, right? You can connect to that database and you can run via crawler as well. We can get that data via crawler as well. Now let this get run. And guys, meanwhile this run, see now we did this entire end-to-end notebook, but in actual project, you will be not be maybe running this one by one, right? How you will be doing? So let me show you one of the example, right? In actual project, when you are developing something, right? I have the same, these things over here, okay? I will show you, let's say in actual project, how things happen. Let first get the result of these things. Yeah, it's completed. Let me see the tables, refresh. See, basically, we are trying to query these things, but this is since in Snappy Parquet format, we are not getting all the result, but let me just click on business. Okay, anyway, insert table. Incident happen. Okay, let me click another table. For every query, guys, you need to pay the charge to Amazon for that, right? Let me click on a table data, proceed. That's just one of the way I wanted to show you. Let me see if this could help. Okay. okay, look like it's in Delta Parquet, but it's in OCR and this CSV and all these JSON files are there. So maybe we cannot query, but ultimately, guys, if you wanted to query that data, you can even query in business layer as well, right? So if maybe I can show you if you wanted to query the data that you have loaded in business layer, the simply what you will be doing, you will go to the your business layer, right? And then your data set, for example, any data set, and then just click on this data, right, to show. Fine, guys. Now, in actual project, the way you would be doing it, you will be not creating running this notebook one by one. So the way you would do, you will be creating the, let's say, jobs. Okay. Let me show you. I just click on a job runs. Right. Create a job. Data ingestion. Right. Take the name of the notebook that you are trying to connect. Okay. Let's say data ingestion is the first thing we need to cover, right? Let's say S3 data ingestion I wanted to first make. Then what I will be doing, guys, I need to create, let's say, basically I can create a task over here, right? So instead of me running manual notebook, I can mention that this is what the notebook I wanted to run, right? And if I just create a task, this task will get created, right? And this task then I can click on a run, right? And I can run now, or I can even schedule. So this in actual code, the way in actual project, the way you will be running the code with the help of this multiple job runs. So you will be creating the jobs, job and pipeline. And see, one of the pipeline that I have just created, right, some time back, just wanted to quickly show you. See, the data staging, right? In the data staging folder, I am connecting to my notebook workspace, right? And this is the, if I click on here, data staging, and this is the, if I click, it's a notebook only, right? Type is notebook, serverless. Let me show you that thing. Type is notebook, right? Workspace, and then compute, select dependent on. Rest of the thing, let it be as it is. So you see, it's pointing to my S3 data ingestion. That's what I want to try to say, right? So you can create any notebook and make the dependency. See, first of all, I create a one notebook and I'm pointing to S3 data ingestion. Then after success of S3 data ingestion, I'm then calling S3 basically stream data ingestion. So that sort of things you can do and configure and then run it as a run now or schedule. So those things you'll be doing when you are running job, but actually you first running, creating the job via this notebook and all, it's not a big task. You can do it's very easily, but getting that end-to-end architecture is very important.